Hello guys, I hope you're doing alright, and here we are in a video about multiplying binomials by binomials. Okay, remember that on the last video we were talking about how to multiply a monomial by a polynomial. Okay, so in that case we were using the distributive property, and here we will see the same. Okay, so let's remember some important stuff like the distributive property. We need to remember that we use that when we have for example, a monomial that multiplies different terms like a binomial, a trinomial, or a polynomial. And we also use that here when multiplying binomials by binomials, all right? So we will keep in mind the distributive property and also the exponent properties. So remember that when we multiply two variables, we need to add the exponents, okay? When multiplying variables, adding exponents, and when we divide variables, we subtract exponents. But here, actually here, we're going to use the multiplication properties when using exponents. And finally, once we use the distributive property and once we apply the exponents property, we need to check if we have like terms. So they should be combined, okay, as usual. All right, guys, so let's start here. With this example, we have 3x plus 2y times 3x minus y. Okay, so we have two binomials. The first one is this, 3x plus 2y, and the second one is this. So we are going to start using the distributive property here. We start with the first term, okay? So we start multiplying 3x, the first term, by the first term of the second binomial. Okay, so we multiply 3x times 3x, and that will be, remember, we multiply the coefficients. So 3 times 3, which is 9. So we have 9. We have the variable x times x, which is x. We add the exponents. 1 and 1 will be 2. So 9x to the power of 2. Then we continue by multiplying the same first term by the second term of the second binomial. So 3x times minus y. So the signs first, positive times negative, which is negative. So we write negative. And 3x times y, they are not the same variable, so we don't need to add any exponents here. We just keep the same the original variables. All right, so it will be 3xy. 3xy. We make like we do like a fusion between x and y, so 3xy. And that's it. We're done with the first term. Then we continue with the second term, so 2y times 3x, and the same. We can organize the variables like, for example, in alphabetical order. So we can write first the x and then the y, like this, 3xy. We can do the same like right here. So we multiply the coefficients, 2 times 3, which is 6. So plus 6, and the variables are x and y. So we write them together, 6xy. And then we multiply the second term by the second term of the second binomial. So we multiply 2y times minus y. So positive times negative, which is negative, all right? So 2 times minus 1, which is minus 2. And here we have the same variables. We have y here and y here. So we just write the same variable, y, and we add the exponents because 1 and 1 will be 2. So we just add the exponent, and that will be right here. Okay, guys, so this is the first step. We already checked the distributive property by multiplying, and then we use the exponents property when adding the exponents. All right, so finally, we need to check if we can combine like terms. So what are the like terms here? Let's see. For example, here we have a 9x2. This term is alone. It doesn't have any partner to add or subtract with the same variable and exponent. So that would be like that. Okay, so we write 9x squared. We keep the original term. So 9x squared. And then let's check, for example, here we have 3xy. Which terms have the same variables here? So we have 3xy and we also have 6xy. So we keep the same variables and we add the like terms as usual. So we just add minus 3 plus 6, which is plus 3xy, okay? So plus 3xy. So we already combined this, okay? We already combined this and this. And finally, minus 2y squared, okay? So we keep the same term because it doesn't have any partner to be added or subtracted, okay? So we have minus 2y squared. Okay, we cannot simplify this anymore. This is our final expression, guys. Okay, this is our final answer here. So 9x squared plus 3xy minus 2y2. All right. Okay, very good, guys. So let's see another example. Now we have fractions. Okay, we can also find fractions in these cases. All right. So let's see. But the process is actually the same. So let's start, guys, by multiplying the first term, okay? So we have 1 over 2x. We multiply this by the first term of the second binomial. So we only have an x here, so it's like you had a 1, like an invisible 1 that we have here. So we just multiply 1 over 2 times 1. We already know how to multiply fractions, guys. So that would be 1 times 1 and 2 times 1. So it would be 1 over 2. So we have 1 over 2, and then we have the variable x times x. So we keep the same variable, x, and we add the exponent. So since we don't have anything here, they have a 1 as an exponent. So 1 plus 1 will be 2. So x squared. Okay, so already the first term. And then we multiply the first term, 1 over 2x times 4 over 3. Okay, so here in 4 over 3, we don't have any variables. So we just multiply the coefficient. So here is 1 over 2 by 4 over 3. So we multiply this, we do this operation. We know that we multiply 1 over 2 times 4 over 3. All right. So remember that we multiply fractions, we multiply numerators. So 1 times 4, which is 4, and 2 times 3, which is 6. So finally, guys, we can simplify this fraction by 2. So 4 divided by 2, which is 2, and 6 divided by 2, which is 3. So the final fraction here will be 2 over 3. Okay, so now the sign, this is positive and this is positive. So positive times positive will be positive again. Here we have 2 over 3. That's the result of the multiplication, 1 over 2 times 4 over 3. And don't forget the variable, because we multiply x by a coefficient, so we keep the variable, all right? So this is a 3. Okay, and then, guys, we continue with the second term. So here we have, let's change the color here. We are going to multiply minus 3 times x, which is minus 3 times x will be minus 3x. And then we multiply minus 3 times 4 over 3. So we are multiplying like this whole number times 4 over 3. So remember that when we are multiplying by a whole number, we need to write a 1 in the denominator, and we multiply numerators and denominators. So it will be minus 3 times 4, which is minus 12, and 1 times 3, which is 3. So the answer here, we don't have any variables, guys, so we just write the same here. So it will be minus 12 over 3. All right. Okay, guys, so finally we check if we have any like terms here. For example, this, it doesn't have any like term. We have 1 over 2x squared, and we have minus 12 over 3. So they are terms alone, that they don't have any like terms. But here we can see that we have this and this, okay? 2 over 3x and minus 3x. They have the same variable, but different coefficients. So we need to combine the coefficients here. All right, so that will be 2 over 3 minus 3. Okay, so remember, guys, since we have a whole number here, we just write a 1 in the denominator. Okay, And then we need to find the LCD between 3 and 1, which is actually 3. So we multiply this second fraction by 3 in order to get the same denominator. So we multiply by 3, and that will be 3 times 3, 9, 9 over 3. So finally we have here 2 over 3 minus 3 times 3 will be 9 over 1 times 3, which is 3. Okay, so finally they have the same denominators, they are like fractions, and they can be added or subtracted. So 2 minus 9, which is minus 7, and we keep the same denominator, which is 3. All right, so finally, guys, we already have the answer for this part, okay, like this little part. So we just organize the expression, okay? It doesn't change because this doesn't have any like term. So finally we have 1 over 2 x squared. Okay, we have the same, the first term is the same here. And the second term will be, after combining these like terms, will be minus 7 over 3. And the variable x, because they have the same variable x. And finally, we have minus 12 over 3. Okay, so guys, we don't have any other like terms here in this expression. So this is our final answer. This is the final trinomial that we already get. What is the degree of this trinomial? Remember that is the highest exponent, so that will be 2, okay, because this is the greatest exponent here. All right, we have 3 terms, the variable is x, and the coefficients are 1 over 2 minus 7 over 3, and the constant is 12 over 3. So actually, guys, here we could simplify 12 over 3 because they are divisible by 3. So 12 divided by 3, which is 4, and 3 divided by 3, which is 1. So finally, that will be minus 4 over 1, which is actually 4. All right? So we can write the same expression, 1 over 2x squared minus 7 over 3x minus 4. All right? And that will be the final answer, guys. Okay, guys, so that's it today. I hope you really understood. So now we will go to the practice, okay? See you then. Bye-bye.